Yes, see this question. A point moves in a plane xy according to the law x is equals to a sin omega t and y is equals to a into 1 minus cos omega t. So out here x is equals to a sin omega t and y is equals to a minus a into 1 minus cos omega t. So whenever you have cos omega t and sin omega t in conjunction, okay, so that not necessarily in your syllabus, okay, that literally corresponds to circular motion, or most of the time it will correspond to circular motion. Okay, so let's check this one if this is circular motion or not. See, what is my intuition out here? Whenever you have sine omega t and cos omega t in pairs, most of the time it is circular motion. So let's check it. Okay, so out here x is equals to a sine omega t and y is equals to a minus a cos omega t. Okay, or instead of writing a minus a cos omega t, let's write the equation as it is. Okay, y is equals to a into 1 minus cos omega t, or y by a is equals to 1 minus cos omega t, or y by a minus 1 is equals to cos omega t. Okay, or 1 minus y by a, or 1 minus y by a is equals to minus cos omega t. 1 minus y by a should be equals to cos omega t. Okay, now let's check this one. And out here x by a, in this equation x by a is equals to sine omega t. Okay, so we are doing equation 1 square plus equation 2 square. So what will be the left hand side? The left hand side would be x by a whole square plus 1 minus y by a whole square. See the left hand side, x by a whole square plus 1 minus y by a whole square. Okay, and what will be the right hand side? The right hand side would be sine omega t whole square or sine square omega t plus cos square omega t. Okay, sine square omega t plus cos square omega t. And what is sine square theta plus cos square theta? Sine square theta plus cos square theta is nothing but 1. So this entire term would be 1. So I can rewrite this equation as x by a whole square plus 1 minus y by a whole square is equals to 1. Okay, so out here this is nothing but a equation of a circle. See, this is the equation of a circle. Okay, now the question is asking the distance traveled by the point during the time period tau. Acha. Since this would be moving in a circular motion, okay, the velocity out here, what would be the velocity out here? See, the velocity vector would in circular motion, as the particle is moving in this circle, okay, the velocity vector would change with respect to time. Okay, that corresponds to that takes care of this sine omega t and cos omega t. Okay, but what is the actual magnitude of velocity? See, most of the time the magnitude of actual velocity would also remain constant. Okay, let's check it out. If the velocity, if the magnitude of the velocity remains constant out here, understood what I'm trying to do? So v vector is equals to dx by dt I plus dy by dt j. What is dx by dt? V is nothing but, we have to differentiate this term with respect to t, is equals to a omega cos omega t I plus what is this term with respect to j? See, this is nothing but, we have to differentiate this entire term with respect to t, so it's nothing but minus of minus of minus sine minus omega sine omega t j, and this minus and this minus would become plus out here. So this minus and this minus becomes plus out here. Okay, so a omega sine omega t, a omega sine omega t. See out here. If you differentiate this term, let me differentiate this term and show you. Okay, I'm differentiating this term. Dy by dt is equals to dA by dt minus d into a cos omega t by dt. Okay, this is constant and this would be 0. This would be nothing but minus of minus a omega sine omega t. Okay, and this minus and this minus becomes plus, and the remaining would be a omega sine omega t. That's what I wrote out here, a omega sine omega t. Understood? So let's erase this one. Now what I'll try to do is I'll try to find out the magnitude of this velocity vector. Okay, what's the magnitude of this velocity vector? Or v magnitude would be under root of a omega cos omega t whole square plus a omega sine omega t whole square. Okay, or v vector would be equals to a square omega square cos square omega t plus sine square omega t under root. If I solve this one, or magnitude of velocity in the circular path is nothing but a omega. So see, the particle moves in a circular orbit with a constant speed of a omega. Okay, now the question is asking what is the distance it traveled in time period t. But distance is nothing but speed into dt, but this is nothing but speed out here. Understood my approach or what I'm trying to do out here? Or distance is equals to a omega dot dt from 0 to t, or distance is equals to a omega t. Okay, the second part of the question was find the angle between velocity vector and acceleration vector. Angle between, not the speed, angle between velocity vector and acceleration vector. Acceleration vector. Okay, whenever vector is asked, what do? We use dot product. So v dot a is equals to modulus of v or magnitude of v into magnitude of a into cos theta. Okay, out here we don't know the magnitude of a out here. Okay, Acha. To find out the magnitude of a, one more trick that I'm going to share with you is whenever there is a circular motion and the speed is constant in the circular orbit, okay, there is only one force or only one acceleration that is required to keep this particle in a circular orbit, and that is radial acceleration. That means the acceleration will always be directed towards the center of the circle. That means when the particle is out here, the acceleration would be in this direction. When the particle is out here, the acceleration would be in this direction. When the particle is out here, the acceleration would be in this direction. That means at this instance the acceleration would be in this direction, at this instant the acceleration would be in this direction, at this instant that acceleration would be in this direction. At this instance, that means when the velocity is this one, acceleration would be this one. When the velocity is this one, acceleration would be this one. When the velocity is this one, acceleration would be directed towards the center. When the velocity is this one, acceleration would be directed towards the center. Okay, so this is our trick out here. But let's verify this trick. How do I verify this trick? See, in a circular motion, okay, see out here, whenever the velocity in this direction, acceleration is towards the center, no, the acceleration will always be towards the center, and that kind of acceleration is called radial acceleration. Notice one more thing out here. The angle between velocity vector and acceleration vector is always 90 degree. Okay, and what happens if cos phi is equals to 90? So this becomes 0. So let's check it out. Okay, okay, what's the value of a? I need to find out a also, no? So what's the value of a? A vector is nothing but dvx by dti plus dvy by dtj. Okay, what is the vx component? X component of velocity is nothing but this one, and when we differentiate this with respect to time, we get a is equals to minus a omega square sine omega t plus I. This is the I component of acceleration plus a omega square cos omega t j. Okay, so let's find out v dot a. This is the value of a out here I found, and this is the value of v that I found in earlier slide. So v dot a is nothing but, instead of solving for the entire equation, I'm solving only for v dot a because my intuition is telling v dot a will be equals to 0. And if v dot a is equals to 0, this cos theta will also be equals to 0 irrespective of the magnitude of v or a. Understood? So v dot a is equals to how much? A omega cos omega ti plus a omega sin omega t j, okay, into dot minus a omega square sin omega ti plus a omega square cos omega t j. Okay, now when you solve this one, okay, now we'll solve this one in next slide. Or when you solve this one, what do we get? V dot a is equals to multiply I with I and j with j. So a square, this a out here is constant. This a out here is constant and this a out here is acceleration. Okay, don't confuse the two. Okay, a square omega cube minus a square omega cube into sine omega t cos omega t. Okay, and j with j plus a square omega cube sine omega t and cos omega t. See out here, I multiplied with I becomes 1, j multiplied j becomes 1. Since this is a dot product, this is a scalar quantity and this is also a scalar quantity, and both these quantities are equal. One is with minus sign, one is with plus sign, so they'll cancel out to be 0. So v dot a is equals to 0. Okay, therefore v dot a is equals to 0. Therefore in v dot a is equals to magnitude of v into magnitude of a into cos theta. If this is equals to 0, that means cos theta is equals to 0, and cos of what value is equals to 0? When theta is equals to pi by 2 or 90 degree. So when cos 90 is equals to 0 or cos pi by 2 is equals to 0. So whenever you get cos pi by 2, that means the velocity and acceleration in a circular motion are always perpendicular to each other. velocity and acceleration in circular motion are always perpendicular to each other. Okay, let's look at this question. Okay, a particle moves in a plane xy with constant acceleration w directed along negative y-axis. So this is positive y-axis, this is negative y-axis, this is positive x-axis, and this is negative x-axis, and there is a acceleration in this direction. Okay, the equation of motion of the particle has a form y is equals to ax minus bx square. So y is equals to ax minus bx square, where a and b are positive constants. Okay, find the velocity of the particle at the origin of coordinates. Okay, so what the equation is saying is that, see, find velocity at 0 comma 0, so that x is equals to 0 and y is equals to 0. In this question, what you have to do is you have to find the velocity in terms of as a function of a, b and w. How do I know? Because a, b and w are only the constants out here. There is no numerical parameter out here. And how do I solve this question? See, you have to play around with equation. Some of the equation that I can figure out is ds by dt is equals to v, dv by dt is equals to a. So you have to play around with this equation and find out the value of v at x equals to 0, y is equals to 0. There is one more thing we need to understand out here. The concept of mathematics called chain rule. What chain rule says is that, suppose I am to differentiate dy by dt. Okay, now see this equation. There is no concept of t out here. There is no parameter of t out here. What I can do is I can first differentiate this with respect to x and then differentiate x with respect to 2. What I mean is that dy by dt can also be written as dy by dx into dx by dt. See, so I can first differentiate this with respect to x and then multiply by dx by dt. So let's apply chain rule out here. Dy by dt is equals to d into ax minus bx square divided by dx into dx by dt. Okay, by applying chain rule, what I'm essentially doing is that I'm cutting this out and I'm doing dy by dt. This is essentially nothing but dy by dt. Okay, or dy by dt is nothing but, if I differentiate this parameter with respect to x, what do I get? A minus 2bx. So a minus 2bx into dx by dt. Understood this one? Now what is dy by dt? Dy by dt is nothing but vy, and what is dx by dt is nothing but vx, or y component of velocity and x component of velocity. So I can rewrite this equation as vy is equals to a minus 2bx into vx. Okay, or out here vy is equals to a minus 2bx into vx. Now let's put at x is equals to 0, at x is equals to 0, what happens to this equation. And why am I putting x equals to 0 out here? Because you have to find the velocity at x equals to 0, y is equals to 0. So let's put x equals to 0 in this equation. What do I get? vy is equals to a minus 2 into b into 0 is becomes 0 into vx. So this is our first equation. At x equals to 0 and y is equals to 0, y component of velocity is equals to a times x component of velocity. Okay, now what we need to do is we need to introduce a term of acceleration, or w. How do I do that? I differentiate velocity with respect to time, or dvy by dt is equals to a minus 2bx into vx, okay, by dt. See, I can separate this term, or dvy by dt. Let's solve this first. Is equals to, we take vx constant first, then dA minus 2bx by dt plus a minus 2bx, okay, into dvx by dt. What is dvx by dt is nothing but x component of acceleration. What is dvy by dt is nothing but y component of acceleration, which is given as minus w in the question. Okay, so out here minus w is equals to vx. What happens when if we differentiate this term with respect to t? First you have to differentiate this term with respect to x and then multiply by dx by dt. I'm applying chain rule out here. Okay, or is equals to vx into minus 2b into dx by dt into dx by dt plus a minus 2bx into ax. Okay, and what is dx by dt is nothing but vx, or minus omega is equals to vx minus 2b vx square plus what, a minus 2bx into ax. I have to put the boundary condition at x equals to 0. Okay, the x component of acceleration is equals to 0. How do I know that? Because in the question it is given acceleration exists only in negative y direction. That means there is no component of x component of acceleration. So if there is no x component of acceleration, ax will always be equals to 0. Okay, or if I solve this, minus w is equals to minus 2b vx square. Okay, and vx is equals to, or w is equals to 2b vx square. Okay, or vx square is equals to w by 2b. This is our equation number 2. From equation number 1, see, vy is equals to a into vx. Can I substitute the value of w by 2b out here? Of course. So vy square is equals to a square into vx square. Why I'm doing square, you'll understand. See, vy square is equals to a square into, what is the value of vx square? W by 2b. So into w by 2b. Now check one. I have the x component of velocity, y component of velocity. What is total velocity? Total velocity is nothing but root over, or magnitude of velocity is nothing but vx square plus vy square. Okay, and vx square plus vy square is nothing but, what is vx square? Vx square is nothing but w by 2b. Okay, plus vy square. Vy square is nothing but a square w by 2b under root. Okay, this is our equation of velocity. Or v is equals to, you can take w by ab, sorry, w by 2b common, 1 plus a square. Okay, this is what is our equation of velocity at 0 comma 0. Understood the question? This question is nothing but playing around with the equation. See, look at this question. Okay, a small body is thrown at an angle to the horizontal with an initial velocity v0. Neglecting the air drag, find the displacement of a body as a function of time. So what the question is essentially asking is, you will remember the formula, S is equals to ut plus half at square. Okay, this is what the question is asking, but the displacement vector is equals to velocity vector into acceleration vector into t square. Problem is, how do I derive this one? You all know these three relation, that v is equals to ut. The first relation of kinematics is equals to v is equals to u plus at. Okay, second relation is s is equals to ut plus half at square, and the third relation is v square is equals to u square plus 2as. Okay, these are vector quantities. And the third equation is scalar. Okay, a dot is a scalar quantity. Dot product of two vector quantities out here is a scalar quantity. Okay, but how are this equation derived? Okay, let's check out here from the three fundamental principles. Okay, so can I say for this one dv by dt is equals to, what is dv by dt? Acceleration. Okay, or dv is equals to a dt. Okay, what is a? A is nothing but the acceleration. Okay, or v is equals to at plus some constant. Okay, now to find out this value of constant, we need to put the boundary condition. The boundary condition out here is at initial time, at t is equals to 0, velocity is equals to initial velocity. Okay, if you put that boundary condition in this equation, how do we get? We substitute v with u is equals to a into 0 plus constant, or the value of constant is equals to u. Value of constant is equals to u. This is, I'm doing indefinite integral. Okay, you can directly do definite integral and directly write v from lower limit is equals to u to v is equals to a into t, t from 0 to t. Both this solution will have the same answer. See, v minus u is equals to at, or v is equals to u plus at. This is the process of direct integral. And for indefinite integral, what do? We substitute this u out here in this value of constant, or v is equals to at plus u, or v is equals to u plus at. This is our first equation. Okay, so we got the first equation of motion, v is equals to u plus at. How do we obtain this one? S is equals to ut plus half at square. See, we do know that, I'm doing it out here. Okay, ds by dt is equals to v, and what is the value of v? Value of v is nothing plus u plus at, or initial velocity plus acceleration into time. So if we substitute u plus at out here in place of v, let's see what happens. Or ds by dt is equals to u plus at. Okay, or if we integrate this one, we get ds is equals to u plus at into dt. Okay, or ds is equals to ut plus at square by 2 plus some constant. Okay, not ds, is. Okay, okay, now what is the boundary condition out here? Boundary condition out here is that at t is equals to 0, displacement is equals to 0. So when you put this boundary condition out here, you put the value of t is equals to 0, you put the value of s is equals to 0. We get the value of constant is equals to how much? If you do that one, you get the value of constant is equals to 0 out here. See, when you put s is equals to 0 and t is equals to 0, we get constant, the value of constant to be 0. So out here, s is equals to nothing but ut plus half at square plus 0. Okay, this is the second formula. And the third formula, v square is equals to u square plus 2as. V square is equals to u square plus 2as. Okay, how do we derive that? This is nothing but acceleration can also be written as v dv by ds. Well, I've learned that in few questions earlier. So out here, a into ds is equals to v dv. Okay, or a into s is equals to v square by 2 plus some constant. Okay, and we know at s is equals to 0, that means at initial displacement, the boundary condition out here is at initial displacement, or when s is equals to 0, the velocity is equals to initial velocity. Okay, so you put the boundary condition, you put this boundary condition out here, what do you get? A into 0 is equals to u square by 2 plus some constant. Okay, or out here constant is equals to minus u square by 2. Okay, so if I put this constant back into this equation, what do I get? As is equals to v square by 2 minus u square by 2. If I take 2 common, 2 into as, I took this 2 common out here and send it to the left hand side. 2as is equals to v square minus u square, or v square is equals to u square plus 2as. Okay, see, the question asked only this relation, s is equals to ut plus half at square. But since you are learning kinematics, whenever the acceleration constant, there are three formulas you needed to learn: v is equals to u plus at, s is equals to ut plus half at square, and v square is equals to u square plus 2s. This my entire effort was to explain the origin of these formulas. Understood? Or the derivation of these formulas. Okay. Acha. The notable point I'm making out here by this derivation is, whenever you are applying these three formulas, the time is always started from 0 and the displacement is always started from 0. Okay, that means initial time is always 0 and initial displacement is always, or initial, the uh, position vector, or the position vector always started from 0. Okay, the s, initial s is also always equals to 0. That means at t is equals to 0, s is equals to 0, and for v is equals to u plus at, at t is equals to 0, s is equals to 0. These are the two conditions you need to remember in these three formulas. What are the conditions? At t is equals to 0, s is equals to 0, and velocity is equals to initial velocity, or velocity is equals to u. These are the important points that I am trying to say in this derivation. Okay. Achha. Let's look at the third part of the question. The mean velocity vector averaged over the first t seconds over the total time of motion. See out here. Out here you have to understand the nature of projectile motion. Suppose a projectile motion is there. Okay, it is thrown with initial velocity v0 at an angle theta. While going, the projectile will go like this. While landing, the projectile will also land with velocity v0 at an angle theta. That means a projectile is symmetric in the y-axis. Understood? That means the velocity out here will be equals to velocity out here. Velocity at the topmost point, or the vertical component of velocity at the topmost point, will be 0. Okay, the velocity vector out here in this direction will be equal to the magnitude of velocity vector in this direction. So this is how projectile works. Okay, so what is average velocity? Average velocity. Average velocity is nothing but total displacement, total displacement divided by total time, divided by total time. Okay, in this question it is asking two things: averaged over the first t second, this is our question number 1. Okay, averaged over the first t second, point number 1, question number 1, and averaged over the total time, this is our question number 2. So I'm solving for question number 1, average velocity for the first t seconds. So what is the displacement for the first t second? Displacement is equals to ut plus half minus g t square. Why minus g? I'm taking this as positive, this as negative, this as positive, and this as negative. Or instead of doing minus gt, or instead of taking ut plus half gt square, I'm taking the vectors of this equation. Okay, if I'm taking the vectors, automatically when you put the vectors, the sign would automatically come out as negative out here. So total displacement is equals to ut plus half gt square. What is the total time? Total time is equals to t. Time is equals to, or total time is equals to t. So the average velocity of averaged over first t seconds is equals to ut plus half gt square divided by t. Okay, and time is a scalar quantity, so you can take time common out here. Or average velocity is equals to u vector plus half g vector into t. This is the formula for average velocity averaged over the first time or first t seconds. Okay, now see, we need to find out the average for the entire projectile, or time of flight for the entire projectile is t. Let's say time of flight for the entire entire projectile is tau. Okay, this is my assumption out here. Okay, now I must little bit play with equations out here. We know that v is equals to u plus at, or v vector is equals to u vector plus a vector into t. I can literally say that v dot v is equals to u plus at into u plus at. Okay, now why did I do such a thing? Because out here v dot v is nothing but v square, and v square becomes a scalar quantity. See, if I use just v vector out here, okay, I have to take in angle, or I have to take in consideration of the angle theta out here because v vector. But as soon as I make it v dot v, I don't have to account for the direction of velocity vector because v dot v is a scalar quantity. And one more thing, what am I trying to do out here? Okay, what I'm trying to do is I'm trying to replace this time t in terms of g and initial velocity v naught. Understood? Out here what? Initial velocity was v naught plus half gt. Okay, so what I'm trying to do out here is I'm trying to substitute this t in terms of v naught and g. Understood what is my equation? What I'm trying to do? Okay, so v dot v is nothing but v square is equals to, let's multiply this by the u dot u is nothing but u square out here. U into at is nothing but u dot a into t. Achha. Now this u dot a into t plus u dot a into t, and this is nothing but at into a dot a into t, or a square into t. See, if you multiply this entire term, this will come as this term. Now let's simplify this term, or v square is equals to u square plus 2u dot a dot t plus a square t. Okay, and what is this u square? U square is nothing but initial velocity, which is equals to v naught square, but u square is equals to v naught square. Okay, now for the entire path of projectile, see, I'm applying some boundary condition out here. Boundary condition means boundary condition. Okay, at the end of projectile the velocity is v naught, so at time t is equals to 0 the velocity of projectile is v naught. As the projectile goes out here, at the end of projectile, as soon as the projectile hits the ground, what is the velocity of the projectile? V naught. So at time t is equals to tau, velocity of the projectile is v naught. So time is equals to tau, total time of projectile, or total time of projectile, or total time of motion. What? Velocity is equals to v naught. Understood? Now I have to substitute this t out here and this v naught out here. So I'll get the parameter of time in terms of a, u and t. See out here. U was what? The initial velocity, and the initial velocity was v naught. Okay. And what was A out here? What was A out here? A was nothing but G. In projectile motion, the acceleration due to gravity is always in downward direction. So out here A is nothing but G. So G square. Okay, understood this much. Now let's solve this equation in the next slide. There's a little bit of correction out here. Okay, out here it would be A square T square and G square T square. Why? Because AT into AT is A square T square, which translates to G square T square. Okay, and one more thing, remember this equation. Okay, we have to use this equation to get our answer. Okay, so what I have to do now is apply this boundary condition out here. So T will be substituted out here and V naught will be substituted out here. So V naught square is equals to V naught square plus 2 V naught into G into tau plus G square tau square. V naught and V naught would get cancelled. 0 is equals to 2 V naught G tau plus G square tau square. This and this would get cancelled, or tau is equals to minus 2 V naught G by G square. This tau is nothing but the total time of projectile taken, and we can substitute this tau out here. Okay, if we substitute this tau, out here, the value of tau is substituted out here. And what is the equation? This equation is nothing but average velocity for the time t. So average velocity for the entire projectile would be, if we substitute tau out here, so I'll get delta V is equals to V naught plus half G t for tau. Tau is nothing but minus 2 V naught G by G. Okay, 2 and 2 would get cancelled, minus would come outside, and V is equals to V naught minus G V naught G by G square. Okay, this equation is nothing but playing with equation. This question doesn't essentially just plays with the equation out here. In simplified version, the average velocity for the entire projectile would be C. For average velocity, the displacement in a projectile only occurs in x component. So range of the projectile divided by the time of the projectile. Okay, divided by time of projectile. And for any duration, average velocity for any duration is given by this equation. Okay, these are nothing but vector equation. Acha, you all remember the formulas for projectiles? The formula for time of flight, range and height. We'll derive those entire thing in this question. Okay, what is the formula for time and flight? See, one easier way to remember is T R H. This is alphabetical order. Okay, alphabetical order. That means A B C D E F G H I J K L M N O P Q R S T. So I'm going alphabetical order from the bottom to top. Okay, out here is equals to U sin theta by G, U sin theta by G, and U sin theta by G. Okay, out here. Now let's push 2 U sin theta by G out here. Since 2 already appeared out here, it will go at the top. U square, and there will be another 2 introduced out here. Okay, now out here, since it always has a U out here or 2 out here, so square this 2, okay, would become square out here, and I will introduce new 2. So just write u sine theta and keep pushing 2 in each steps. Okay, what this question I'm trying to do is I'm trying to derive this formula for time of flight, range and height. Okay, this is a easier way to remember this formula. So see, a body is thrown from the surface of earth at an angle alpha. Okay, this is the projectile motion. The body is thrown at an angle alpha. See, after instead of using alpha, I'm using theta. Okay, okay, with the horizontal with velocity u. Okay, instead of using v naught, I'm using u, assuming the air drag to be negligible or air friction force to be negligible. Find the time of motion. So whenever there is projectile motion, see, all these formulas are only valid for ground to ground projectile. Okay, whenever there is projectile motion, you can always component them into x component and y component of motion. See, x component of motion and y component of motion. Okay, so for the entire projectile, how do I find out the time of flight? See, for the time of flight, can I say the displacement in y component will be 0? See, the y component of displacement started out here, the y component of displacement ended at y is equals to 0, started at y is equals to 0 and ended at y is equals to 0, and we apply the formula s is equals to ut plus half at square. Out here upside is positive, downside is negative, right side is positive and left side is negative. Whenever you are applying projectile motion, always give the sign or always assign the coordinate system before dealing with vectors. Okay, so out here u is nothing but u sine theta, t is nothing but total time of flight, acceleration is nothing but g, and s out here displacement in y direction is nothing but 0. So if we use 0 is equals to u sine theta into t minus half g into t square. So if we cancel out the t, what do I get? A total time of flight is equals to 2u sine theta by g. This is the first equation that I derived. Okay, this is the first equation that I derived, the time of motion. Now see, for the second part, the maximum height of the ascent and the horizontal range. See, for maximum height, okay, what do you use? We use v square is equals to u square plus 2s. See, if this is the maximum height h, okay, the formula for h would be u square sine square theta by 2g. But how do we derive this? You again use the y component of velocity. In y component of velocity, can I use v square is equals to u square plus 2as? Okay, now see, in y component, what is final velocity at maximum height, or what is the y component of velocity? At maximum height, the projectile would be parallel, or the velocity of the projectile would be parallel to the ground. So y component of velocity at maximum height is equals to 0. Understood this one? Y component of velocity is at maximum height is equals to 0. Y component of velocity or y component of initial velocity is nothing but u sine theta. A is nothing but minus g, and s is nothing but maximum height. So I can simply say that 0 is equals to u square sine square theta minus 2g h, or h is equals to u square sine square theta by 2g. This is the maximum height of the projectile. Okay, h max or h max. This is the formula of this one. Now for the horizontal range. Horizontal range means nothing but the horizontal distance covered. Okay, horizontal distance covered is given by this formula. And how do we derive this formula? u is the x component, and s is equals to ut plus half at square. See, in projectile motion, the x component of acceleration is always 0. Why? Because gravity acts only in y component. So acceleration out here is 0. What is t? T is nothing but time of flight, or the total time of flight. So t is nothing but 2u sine theta by g, and u out here is nothing but what? X component of velocity or x component of initial velocity, which is nothing but u cos theta. U cos theta. The s out here is nothing but the horizontal range. So if you solve this formula, r is equals to how much? 2 or u square into 2 sine theta cos theta by g. Okay, in trigonometry there is a formula that sine 2 theta is equals to sine theta into cos theta, or 2 sine theta into cos theta. So can I substitute this 2 sine theta cos theta into sine 2 theta, 2 sine theta cos theta, sine 2 theta, 2 sine theta cos theta, sine 2 theta. So if I solve this r out here, r is equals to how much? R is equals to u square sine 2 theta by g, which is the basic value of r. Okay, we derive this one out here. Now see the second part of the question. At what value of angle alpha or theta that we used in the question will they be equal to each other? That means what is the value of theta when the maximum height and the maximum range would be equal? Okay, what is the formula for maximum height? U square sine square theta by 2g. And what is the formula for maximum range? U square sine 2 theta by g. Okay, so when is maximum height is equals to range? H is equals to r when u square sine square theta by 2g is equals to u square sine 2 theta by g. G and g would get cancelled, u square and u square would get cancelled out here when sine square theta by 2 is equals to sine 2 theta. How can sine 2 theta be written as 2 sine theta and cos theta? So out here sine square theta and sine theta would get cancelled. So out here sine theta is equals to 4 cos theta, or sine theta by cos theta is nothing but tan theta is equals to 4, or theta is equals to tan inverse 4. So when theta is equals to tan inverse 4, the maximum value of range, the value of range and the value of height would be equal. Let's look at the third part of the question. The equation of trajectory y is equals to x, where y and x are displacement of the body along the vertical and horizontal component respectively. So this is the vertical component y-axis, this is the horizontal component x-axis, and the projectile occurs in this manner with initial velocity u along this direction at an angle theta. So what we must do is we must make an equation of this line, and how do I make an equation of this line? See, if I take the x component of velocity, x component, and out here y component, in this equation there must be no parameter of time. Okay, so out here can I apply s is equals to ut plus half at square? In the y component also s is equals to ut plus half at square. What is s? The displacement in x-axis. What is u? The initial component of velocity in x-axis, u cos theta, and time t is t out here. The acceleration in x component is always 0. So from this equation, can I get x is equals to u cos theta t, or t is equals to x by u cos theta? Okay, acha. Now see, from this y component of equation, what do I get? S out here is nothing but y. E out here is nothing but u sine theta. A out here is nothing but minus g. Okay, see, t out here. Can I substitute this t out here? Of course. So y is equals to u sine theta into t. What is the value of t? The value of t is nothing but x by u cos theta minus half g t square. Again, what is the value of t? X by u cos theta whole square. Or if I simplify this, y is equals to u and u would get cancels. Sin theta by cos theta is nothing but tan theta. So x tan theta minus half g x square by u square cos square theta. Okay, this is the equation of a projectile or y in terms of x. See, there is one more interesting way of writing the equation of projectile. Remember, what was the formula for range? Range is equals to u square sine 2 theta, or sine theta cos theta by g. Okay, this was the formula for range. Okay, can I say r square is equals to 4 u square sine square theta cos square theta by g square? Okay, so can I take u square cos square theta? I'm writing this equation out here. Okay, or r square g square by 4 u square, sorry, by 4 sine square theta is equals to u square cos square theta. Okay, and what was the value of u square cos square theta? Can I substitute this u square cos square theta out here? Of course. So what I'll try to do now is I'll try to substitute u square cos square theta out here, or y is equals to x tan theta minus half gx square by, what's the value of u square cos square theta? Is nothing but r square g square by 4 sine square theta. R square g square by 4 sine square theta. So 2 and 2 would get cancelled, g square and g would get cancelled, and that equation would be x tan theta minus 2x square sine square theta by r square g. This is our equation. Okay, now let's move the fourth part of the question. The curvature radius of trajectory at its initial point and its peak. See, you have to understand some concept of circular motion out here. In a circular motion, suppose a body is out here. The body is moving with velocity v. What's the radial acceleration? Radial acceleration is nothing but v square by r, where r is the radius of the circle. Okay. Similarly, the projectile follows a parabolic path. Okay, this is not a circular path, this is a parabolic path. But even in parabolic path, there is a constant acceleration in downward direction. So suppose I want to take the radius of curvature at this point. Okay, see out here. If I take theta angle or whatever the velocity out here v, and suppose v1 theta 1, okay, the horizontal component of velocity would always be equals to initial velocity cos initial projection. So horizontal velocity is always u cos theta, u cos theta. So this velocity would be, I'm comparing this horizontal velocity with u cos theta. And what's the acceleration out here? The acceleration at any point is equals to g. See, okay, so acceleration is equals to g. This acceleration is equals to g. So can I use this formula? Can I use this formula and write g is equals to v square? What is v square? U cos theta whole square divided by radius of curvature. Okay, and radius of curvature is equals to, this is radius of curvature, r is nothing but the radius of curvature, u square cos square theta by g. So this is our fourth part of the question. Let's read the next question. Using the condition of the foregoing problem, draw the approximate time dependence modulus of normal acceleration, tangential acceleration vectors, as well as the projection of total acceleration on this velocity vector direction. What the question is trying to say is that, suppose this was the projectile motion. Okay, this was the projectile motion, and out here, this is the velocity vector. This out here is the alpha out here. What the question is trying to say is that, draw a line normal to the velocity vector and draw a line tangential to the velocity vector. Okay, the direction of g would always be downward. Okay, now see, if this angle is alpha, this angle is 90. How much is this angle? Alpha plus 90 plus x is equals to 180 degree. So this angle is nothing but, or x is equals to 90 minus alpha. 90 minus alpha is nothing but alpha dash, where alpha dash is nothing but 90 minus alpha. And look at this line. Okay, this angle makes 90 degree. So if this is 90 minus alpha, this angle would be alpha. And the question is trying to say, find the component of this g along this line and along this line. So component of a or normal acceleration along this line would be g cos alpha, and tangential acceleration would be g sin alpha. Okay, now what I'm trying to do is, I'm trying to plot the graph of tangential acceleration and normal acceleration with respect to time. So at time t is equals to 0, okay, what's the normal acceleration? So at time t is equals to 0, normal acceleration is nothing but g cos alpha. Okay, it would have some value at the peak point, that means somewhere in the middle, the value of alpha becomes 0 and cos of 0 is maximum. So the graph will look somewhat like this. Somewhere in the middle, the graph would peak out here and then again return to its initial value. Okay, this is the normal component of acceleration. Out here, alpha is equals to 0. Alpha is equals to 0 out here. Okay, now what is the value of g sin alpha? See, at initial, the value of alpha would be something, g sin alpha would be something. Okay, so at the midpoint, what will happen? The value of alpha is equals to 0 out here. So at the midpoint, what will happen? The tangential component of acceleration would be 0. So the graph would look somewhat like this, and again the tangential component would increase like this. So this is the tangential component of acceleration.